Welcome to this tutorial on dimensional analysis. This is a powerful mathematical technique used in physics to check the validity of equations and convert units systematically. Throughout this video, you'll learn how to verify whether physics equations are correct and how to convert measurements from one unit system to another with confidence. This skill is essential for solving physics problems accurately and understanding the relationships between different physical quantities. Dimensional analysis is a mathematical technique that helps us check if equations are valid and convert units correctly. At its core, this method uses three fundamental dimensions: mass, length, and time. These are represented by the letters m, l, and t. By breaking down complex quantities into these basic dimensions, we can ensure that equations make physical sense. Dimensional analysis also simplifies unit conversions by providing a systematic approach. Think of it as a consistency check that helps us avoid errors in our calculations and ensures that both sides of an equation are comparing like with like. Every physical quantity in the universe can be expressed using three fundamental dimensions. The first is mass, represented by the symbol m and written in square brackets as bracket m bracket. The second is length, represented by L and written as bracket L bracket. The third is time, represented by T and written as bracket T bracket. These three fundamental dimensions form the building blocks for all other physical quantities we encounter in physics. By combining these basic dimensions in different ways, we can express velocity, force, energy, and countless other quantities. Now let's look at some common physical quantities and their dimensional formulas. Velocity has the dimensional formula bracket LT to the power -1 bracket, which means length divided by time. Acceleration is bracket LT to the power -2 bracket, representing length divided by time squared. Force has the dimensional formula bracket MLT to the power -2 bracket, which combines mass, length, and time. Energy is expressed as bracket ML squared T to the power -2 bracket. Notice how all these derived quantities are built from our three fundamental dimensions of mass, length, and time. Understanding these dimensional formulas is crucial for checking equation validity. The principle of homogeneity is the key rule in dimensional analysis. This principle states that both sides of any valid equation must have exactly the same dimensions. Additionally, we can only add or subtract quantities that have the same dimensions. You cannot add meters to seconds or mass to time. If you check an equation and find that the dimensions on the left side do not match the dimensions on the right side, then you know immediately that the equation is incorrect. This makes dimensional analysis an extremely powerful tool for catching errors in physics equations before you even start calculating numerical values. Let's verify the equation v equals u plus a t, which describes motion with constant acceleration. On the left side, we have velocity v, which has dimensions bracket lt to the power -1 bracket. On the right side, we have initial velocity u, which also has dimensions bracket lt to the power -1 bracket, plus acceleration a times time t. Acceleration has dimensions bracket lt to the power -2 bracket, and time has dimensions bracket t bracket. When we multiply these, we get bracket lt to the power -2 bracket times bracket t bracket, which simplifies to bracket lt to the power -1 bracket. Since both sides have the same dimensions of bracket lt to the power -1 bracket, this equation is dimensionally correct and passes our validity test. Converting units using dimensional analysis follows a systematic four-step process. First, write down the given quantity along with its current unit. Second, multiply by conversion factors expressed as fractions, where the numerator and denominator represent equivalent quantities. Third, cancel out the unwanted units diagonally, just like you would cancel numbers in a fraction. Fourth, calculate the final numerical result in your desired units. This method ensures that units are tracked throughout the calculation, preventing common errors. By treating units as algebraic quantities that can be multiplied and canceled, dimensional analysis makes unit conversion straightforward and reliable. Let's convert 72 kilometers per hour to meters per second. We start with 72 kilometers per hour. To convert kilometers to meters, we multiply by the fraction 1,000 meters divided by 1 kilometer. This cancels out the kilometer unit. Next, to convert hours to seconds, we multiply by the fraction 1 hour divided by 3,600 seconds. This cancels out the hour unit. After canceling the units and performing the arithmetic, we get 20 meters per second. Notice how the unwanted units canceled out diagonally, leaving us with the desired units of meters per second. This systematic approach prevents confusion and ensures accurate conversions every time. While dimensional analysis is powerful, it does have important limitations that you need to understand. First, it cannot determine numerical constants or proportionality factors in equations. For example, it cannot tell you whether a formula should include a factor of 2 or pi. Second, dimensional analysis cannot verify equations when multiple terms have the same dimensions but different meanings. Third, it cannot handle trigonometric functions like sine and cosine, exponential functions, or logarithmic functions, because these mathematical operations are dimensionless. Despite these limitations, dimensional analysis remains an invaluable tool for checking basic equation structure and performing unit conversions accurately. Let's review the key takeaways from this tutorial. First, always use dimensional analysis to verify that your equations are correct by checking that both sides have matching dimensions. Second, convert units systematically by multiplying with conversion factors and canceling units diagonally. Third, remember that m, l, and t represent the fundamental dimensions of mass, length, and time that form the foundation of all physical quantities. Finally, keep in mind that both sides of any valid equation must have matching dimensions according to the principle of homogeneity. Master these concepts, and you'll have a powerful tool for solving physics problems with confidence and accuracy.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.